Hi, welcome back to Element 14 Presents. My name is Mark. Today I'll show you how you can build your own RFID reader. And once you build it, you can use it to open a mechanical lock or control a relay, maybe to switch on your computer, whatever you see fit. Okay, so first I'm going to walk you through the schematics. So here we have our RFID reader. We have our ESP32. We have a button. I will use that button to program any new cards because you have to learn the system, the ID of your RFID tag. And since that's unique for every RFID tag, of course, we need to program it. We have our relay or door opener, whatever you see fit. We have a transistor and of course a driving resistor for the transistor. And that's all there is to it. Let me tell you about the components. First we have our RFID reader. We have our ESP32. Then we have our switch, a diode that protects the transistor from the spikes that are generated by the coil. We have our transistor and of course the resistor. And what else we're going to use? We're going to use a breadboard, some headers for the ESP32. Those are or headers, pin sockets I must say. Okay, so we have several options for our relay. Of course we have a standard relay that will drive whatever you want. That is within the power limits, of course, of the relay. But you can use it to switch on your computer or maybe even power up a live socket. That's up to you. We have several locking mechanisms, a very small one, or a small cabinet, or maybe a box. I think I will use this in a Secret Santa project to open a box mysteriously. Of course, we have a bigger size and even bigger size. These are all 12 volts. They're available in different voltages, but this one all use 12. We should work fine with the ESP32 because we can drive the whole circuit at 12 volts. This one in particular I like. It's 5 volts, and the minute you activate it, it will shoot away the opposite end of the mechanism and it will open the door like so, which is nice. So these are the options we're going to explore, and I think it's time to let's start building. Yeah. Okay, so the first thing, I'm going to make this breadboard up to size. For that I use a knife and just carve it. And I should be able to simply break it, like so. Perfect. So there we have our sized PCB, like so. That's easy peasy. Okay, so let me move this under the microscope. Okay, so next I'm going to put the RFID tag reader and the small components. This will be our RFID reader for that, and then I'll be putting that one there. Yep. Okay, so that one goes there. We have our resistor. And then our transistor, why not here? So we can place this one. Yeah, that's nice. Do it like this, and then we place this one. Yeah, and then this one, we'll have to put it diagonal because of the pitch, but that's okay. That one we'll put there. And then of course we have our protection diet. Okay, now all the components are in place, but we do need to interrupt some traces. I'm just going to use a marker to tell me exactly what. Well, the first thing I'm going to do, let's see where this one goes. So we're looking at it like this, and then we need to know that this one needs to be interrupted, and basically all of these for starters. Only the ground, those pins are connected on the ESP32, so we leave those. So that's what we're going to interrupt. Okay, so these are the traces, this one, and we need to interrupt this one. Yep. Oh, I forgot to put the transistor. Oh, thank goodness. Is it? Okay. Yeah, the resistor goes here. So we solve that in a minute. Let me continue. So that one, the base. This one we need to interrupt. Or we can just do it here. Better. So that needs to be interrupted. That one will be connected, and this one goes to ground later. Yeah, that's it. Oh wait, this one also needs to be disconnected for starters. Okay, if there's something in this video that you would like to see more detail for the next time, maybe you want to see more of the soldering or less of the soldering, more on the programming, let us know, and I'll try to keep that in mind for the next video. And there we have it, our controller, and then we're going to hook up this little lock. It's going to be perfect. Now with the hardware done, it's time to move on to the firmware. Let's start programming. Okay, so for this to work, you need to install a library. There are actually 4 libraries are used, but only one you need to install. And for that you go to libraries and you find the RFID MFRC522 version 2 by GitHub community. And I installed version 206. You need to install that. And of course you have to have your boards installed. So the ESP32 boards have to be installed, and I selected to do it ESP32 Dev Kit 1. So let me walk you through the code. Okay, so first we have some libraries to include. We have some define our relay output and our program switch input, and of course the onboard LED we're going to use. By default we're not in program mode. We define some pins for our RFID reader, and then we go to setup. In setup we set some pin directions. Some are input, some are output. We initialize our EEPROM. We want to store in non-volatile memory. And then we initialize our reader, and we add some information about the reader so we know what we're dealing with. Next we're looking at our program switch, whether it was pressed on boot or not. If it's pressed, we enter program mode. If not, we have a normal operation. And then we all go on to the main loop. In the main loop, first thing we do is we check if there's a card present, and if not, then we'll exit and restart the loop. We don't even bother with everything else. But if there is a card present, then this will be a false, and then we continue to this part in which we read the card serial, and again we get information about the serial. Then we convert that serial we just read to a string, and then we check whatever was in memory in our string and we print it so we know. And if we were in program mode, we do want to store our new just read RFID and store it into memory. That's what we do here. But if we're not in program mode, that part is skipped. And then we just compare whatever is in our memory and compare it to what we just read. And if there is a match, then it will open the door or activate the relay. And that's all there is to it. Okay, so don't forget to compile and upload. I can choose this one, upload, which automatically means it will compile and it will upload to the ESP32 if you have it connected. Okay, so now all I need to do is present my ring and it will open. Okay, so my first application for the locking mechanism is going to be my 3D printer. I'll use it to open the door. Why? Well, I do have a curious kid running around who likes to put her, eyes on my 3D printer. Wondering who's using it more. Anyway, this way I can prevent her from opening it. Let's get started. Okay, so this is my printer, and then I'm going to mount this locking mechanism somewhere right here, and this will be attached to the door like so. Yep. And then of course our RFID reader I will put under the glass plate right there, so I can read the RFID tag through the glass. So let's do that. I'll be applying some tape. And here as well. That's two. And the third one. Right about there. That should do it. Perfect. We'll apply the same tape for the counterpart, and later, if this works out, I will use 2-component glue to fix it to the window permanently. And there we have it. So perfect. Still need to connect some wires. Right, and then all I need to do, plug in the cable and connect this to the top plate, which is going to be awesome. So I'm going to wait. Put back the glass plate. So now all I need to do is present my ring and the door will open. This is all I have for you today. I hope you enjoyed it. Remember to visit the Element 14 Presents community. There's a project page where we put all the information you need to rebuild this project. And when you do, let me know what you're going to use it for. I'm very curious. You can also ask me questions there and I'll do my best to answer each and every one of you. While you do that, I'll start working on a new project, but that's something for a whole new video. Until then, I see you next time.